All right, our first question in the weekly review, number 16, we have y equals -2. I know some of you have memorized what type of line that is, but if you don't have that memorized, you can turn it into slope-intercept form. Y equals mx plus b. The x piece is missing, so whenever we've had a term missing, we've been able to put a 0 in its place. The m is our slope. Our slope would be 0. I can make it into a fraction to see my rise and my run. My b is by itself. It's my y-intercept of -2. So I start at -2 on the y-axis. Slope of 0 means we're going to go up 0. And then right or left, it doesn't matter, 1. So I go up 0, right 1, up 0, right 1, and we have a horizontal line. In the second question, we're graphing absolute value. The negative sign out front would cause us to have a vertical reflection. The 2 in front of the absolute value bars would cause us to have a vertical stretch. Adding 2 inside the bars, remember, goes opposite of what we think. So that would be a left 2. The 8 on the outside, the plus 8 would cause us to go up 8. The left 2 and up 8 let us find our vertex. Left 2 means -2, up 8 means +8. Axis of symmetry, always x equals for the vertical line, and it's whatever the x equals at the vertex, which in this case is -2. So if we graph the vertex of -2, 8, and if you want to draw the axis in, now the -2 out front tells us the slope of our right side. So slope of the right side of our graph is -2. You can put it over 1 if you need the fraction. So on the right side of my graph, I go down 2, right 1, down 2, right 1. And then remember, absolute value graph is symmetric, so just reflect each of those points over. And we have our graph. It's that nice V shape. Both sides are straight lines. In the third question, we need to graph the inequality. What we have in the first question, though, is standard form. To graph standard form, we want to use x and y intercepts. To find the x-intercept, we'd put a 0 in for our y. If we put a 0 in for our y, the y term would be gone. It would cancel out, be a 0. So 3x equals 12. In order for 3 times x to equal 12, x would need to be 4. So there's my x-intercept. Now I do the same thing. I put 0 in for my x. The x term would now be gone. Keep in mind, though, it is a -4y we have left. So y would end up being -3 on the y-axis. Now, because it's an inequality, we have to ask ourselves, is it a dotted or solid line? There's no equal sign. There's no equal to, so we're going to have a dotted line. And we just need those 2 points to make a line. Now, we have to decide which side of the line we're going to shade on. We want to shade the side that has the solutions. To be a solution, that means when I put those values in for x and y, the left side of the inequality will be less than 12. To do that, I like to test an ordered pair, a point on my graph. Easiest point to test is 0, 0. I'm going to test 0, 0 to see if it makes the left side of my inequality less than 12. So I put 0 in for x, I put 0 in for y, and see if that makes the left side less than 12. Since I'm multiplying by 0, everything by 0 on the left, the whole left side is 0. Is 0 less than 12? Yes, it is. That's true. 0, 0 made the left side of my inequality less than 12. So I shade the side with 0, 0. Now, if 0, 0 would have been false, I would have shaded the bottom side of the line. Our fourth and final box on the top row, we're just solving the equation. Start by distributing. So we'd get a 6x plus 3 negative 12x plus 4. Now you have 4 different choices here of how you'd like to solve. You can move the 6x, you can move the 3, you can move the negative 12x, or the 4. I like to keep my variable positive if possible, so I'm going to add 12x to both sides. So 18x plus 3 equals 4. I undo my addition next by subtracting 3. So 18x equals 1. To undo multiplying by 18, we divide. Now here's where we have to be careful, and you could put this in your calculator if you needed to show yourself. This is 1 divided by 18. This is taking 1 and dividing it into 18 pieces. So it just stays as 1/18. 18 divided by 1, if this were flipped around, 18 divided by 1 is 18. That's not what we have here though, so just be careful. It's okay to have a fraction for an answer. Leave it in fraction form though. All right, on to the second row we go. We want to solve that equation for x. That's the surface area of a cube. And I want to solve for x. So in order to do that, the first thing I need to move is the 6 that's in front of it. To undo multiplying by 6, we divide by 6. On the left side, I just have SA divided by 6. Then over on the right, we have x squared. Now to undo the square, we take the square root of both sides. Now over on the left, we have that square root left, capital S, capital A divided by 6. There are ways to simplify that further. Those are ways that you will learn in geometry. So for our purposes, we have solved for x. We're going to leave it right as it is. Our second problem in the second row, we're solving absolute value. With absolute value, we have to recall that it's the distance a number is from 0. The absolute value bars are very different from parentheses. I cannot distribute the negative 3 that's out front. I need to start by moving the 10, undo addition by subtracting. We get negative 3. Now instead of distributing that negative 3, to undo the multiplication, I divide both sides by the negative 3. Those two simplify down to 1. Now I'm left with absolute value of x plus 1 equals positive 1. Remember, absolute value is the distance a number is from 0. So there's two different numbers whose distance away from 0 is 1. Positive 1 and negative 1. So that means x plus 1 could equal positive 1, or x plus 1 could equal negative 1. You do need both cases. And there we have our two solutions. Third question, second row, we're solving the inequality. Start by undoing your addition first. And then divide by negative 3. Remember, when you divide or multiply by a negative when solving inequalities, your symbol flips. So now we're going to have a less than or equal to. And if you want to leave that as negative 4/3, you can. If you'd prefer a mixed number of negative 1 and 1/3, that's entirely up to you. Then we go ahead and we graph our solution. And we've got, I'm going to go ahead and do 0, negative 1, negative 2. Now I need thirds. So in order to split each of these wholes into thirds, I just make two little cuts. So negative 1 and 1/3 would be right here, closed circle because it's an equal to. Numbers that are less than, that would make this inequality true, are over on the left side. So if I wanted to, I could test -2. -2 is less than or equal to -1 1/3. So we shade that left side. Last question, second row. Still looking at inequalities. We have a compound inequality, which means we write two inequalities as one statement. The left side is already solved for. X is already isolated. So we do have to solve the right side. So we're going to add 2 to both. 3x is less than 8. Divide by 3. Now for our final answer, we have x is greater than or equal to 8. We still need to bring that side down. Or x is less than, I'm going to change that to 2 2/3 to make it easier to graph. So on my graph, when we have that or situation, our graph is going to be split. So we have out at 8, a closed circle because it's an equal to. Numbers that would work for x to make that true would be numbers like 9 and 10 would be everything to the right of 8. Then we have our 2. Then we have our 2 would be on the left side of 8. Then we'd have 3. Again, to get thirds, I would make 2 little cuts. X is just less than in this case. There's no equal to. So we're going to have an open circle on 2 2/3. Numbers that are less than, that would make this inequality true, are to the left. So if you have an or, remember, your graph should be split. There should be that space in the middle, that gap. All right, onto the third row we go. Now we're solving an absolute value inequality. Same as we saw above with our absolute value equation. I cannot distribute the -3. I need to get the absolute value bars by themselves, and then I can take care of the absolute value. So I'm going to start by undoing addition by subtracting 15. -3, absolute value of x minus 7 is less than or equal to -9. Same as we saw earlier, I cannot distribute the -3. Instead, to undo the multiplication, I have to divide by -3. So I have the absolute value of x minus 7. Now I divided by a negative, so I have to flip my inequality, is greater than or equal to +3. Now I have to do my 2 cases. I have to do my 2 separate cases. So I'm going to have x minus 7 is greater than or equal to 3. And then x minus 7, I have to flip my inequality less than or equal to -3. Add 7 to both sides. X is greater than or equal to 10. X is less than or equal to 4. Now we have to figure out if we're going to combine those two or if we're going to put the word or between them. I like to graph it to help me decide how to write my final answer. So we have, let's just go by 2's, 2, 4, 6, 8, 10, and 12. X is greater than or equal to 10, closed circle on the 10. Values that are greater would be values like 11 and 12 to the right. X is less than or equal to 4, closed circle because of the equal to. And then values that are less than -4 would be values like 3, 2, 1, those to the right. Since we have a split in our graph, it's like what we just saw with our compound inequality in that second row. There's a split, so we're going to use the word or to write our final answer. And yes, you do need the graph as well. All right, so second question. Whoops, sorry guys. Second question in our third row. We want to solve that system of inequalities by graphing. Both of those are in standard form. So We saw standard form earlier. I'm looking at the top one. If I put 0 in for y, my x is 1. If I put 0 in for x, my y is 1. There's no equal to, so this one's going to be a dotted line. This one's going to be a dotted line. Now, since it's an inequality, just like we saw earlier, we have to decide which side of the line to shade. So I'm going to go, there's some extra space down below this. I'm going to test 0, 0. So 0 plus 0, is that greater than 1? So is 0 greater than 1? Nope, that's false. So 0, 0 does not work. That's on the bottom side of my line. So I'm going to shade the top side. Now we do the same thing with our second inequality. I put 0 in for y. My x is going to be 3. If I put 0 in for my x, my y is also going to be 3. So 3 on the x, 3 on the y. And again, we're going to have a dotted line. And we're going to have a dotted line on there. So now let's test our point of 0, 0. So we have negative 0 minus 0. Is that less than or equal to negative 3? So is 0 less than negative 3? No, it's not. So once again, I'm going to shade away from 0, 0, so that top side of the line. And now the final piece of this is we have to shade in where the two shadings intersect. So the solutions for my system are where my two shadings overlap. So it's going to be where my red and blue are. So we're going to be up above. Oops. Try to stay up above there. Up above that blue dotted line. So just where the red and blue shadings overlap is what we're looking for there. All right, our third question in the third row says to solve with elimination. And with elimination, we're trying to get a pair of opposites. So same number, opposite sign. And you could eliminate the x or the y value. So as we look at our system here, we have a 10 for the x and a negative 2. So one choice I could do is I could multiply the second equation by 5. So I get a 10 and a negative 10. Or I could also eliminate the y's. We have a negative 9 and a positive 3. So I could multiply the second equation by 3, and that would get rid of our y's. I'm going to go ahead and eliminate the x's. So I'm going to multiply that bottom equation by 5. I'm going to rewrite everything down here. So we've got negative 10x plus 15y equals 50. Add my equations together. The x's eliminate. For the y's, I have negative 9 plus 15 is 6y. And then I have 45 plus 50 gives me 95. I finish off by dividing by 6. And I get 15 and 5/6 is my y. Now I have to take that value and substitute it into one of my two equations for my y. So I'm going to pick I'm going to pick my first equation. I'm going to pick my second equation because the y is positive. So I have negative 2x plus 3 times. Now 15 and 5/6 is a little bit tougher to put in. So maybe leave that 95 over 6. And we need to figure out how that equals 10. So we get negative 2x plus, that'd be 47.5 equals 10. Subtract our 47.5. Negative 2x equals negative 37.5. Divide by negative 2. And we get x is positive 18 3/4. So my final answer, my x is 18 3/4. My y is 15 5/6. All right, last question, last row, substitution. Now with substitution, we need to try to get one of the variables by itself in one of the equations, and then substitute into the other. My ideal candidate for substitution is going to be this y in the second equation, because it has a coefficient of negative 1. You want to look for negative 1s or 1s to get by themselves. So I'm going to subtract 5x. And I have negative y equals 5 minus 5x. Divide by the negative 1 that's in front. We have y equals negative 5 plus 5x. I need to now substitute what y equals in for y in the first equation. So negative 5 plus 5x equals 11. We need to distribute. Combine my like terms over on the left. Add 15 to both sides. 20x equals 26. Divide by 20. And my x would be 1 3/10, or if you wanted to use 1.3, you could. Then I have to substitute that x back in to find the y. So y equals negative 5 plus 5 times 1.3. So negative 5 plus 5 times 1.3. And my y is 1.5. So final answer, x would be 1.3, y would be 1.5.